Hello, in this video I make a short talk about what was the latest changes here in Tripscode program. And this video is about the system as such, because I finished some connections there already, but still the testing stone or the moment of truth becomes when you wish to delete something from your scene, and that's the harsh part of any system. When you delete something, then you expect the program to run on and become also be in a valid state, so you can exploit it further. And I had this Morph system here, and let's check it out. And it was a lesson for myself also to find those critical bugs in the system. But here we have a two-part object. And one is this, and the second one is the inside there. And the morph list is here, and I have here 3 morph maps applied to those objects. When I select the first one, then those vertices become selected, and I can state that both objects are included in this morph map. We can read it also here, the first object and the second one, and I have morphs also here for them. To see those morphs I need to be in modeling mode, really go into modeling mode, and then I can click and see those morphs applied only to this morph map, the second and the third one. Now the second map is on the other side, and I can also check those morphs that are essentially manipulated vertices in modeling mode. And the third map involves also here 2 objects, because it grabs some vertices from the outer part also, and it has also 3 maps to it. And my intent here was to just delete this middle part of the list here, the second morph map with all its morphs. I can also display this list as object list, object centered view, and here I can see the second representation of the inner system. Here we see objects are listed. First the atom 0 object, and here it then lists 3 morph maps. I can collapse them with its morphs, and then the second object is listed. And the second one has 2 morph maps to it, with 3 morphs. And let's go to this view. Here those are the object morphs, because the system is that the former morphs encapsulate one or multiple object morphs inside, and then so upper value can be drives the other values for the listed objects that are under the map. We see I need to select this the former. Alright, and I go here, Also, this deformer needs to be selected sometimes. I'm not sure why it listed only some objects. But anyway, when I delete this middle section in this list, let's click remove, then I need to be on the top of the task and have a also valid state for this program after this deletion. And I click on this map and I see those vertices really are again selected, and those morphs that were applied to this morph map also work. And the first one also has the state intact. And this was quite a difficult task to achieve in this program. And let's check out this object list also. Here we see that also only 2 morph maps are listed, not 3. And the second one has only one sorry, only one morph map. So, and those morph maps can be applied in the animation also, and when we check out those locators here for them, I go out of the modeling mode and I go into object mode to click those locators, and I just can change the position of this animation rig, and it animates those 2 objects, and while animating I can then dial here for those morphs. I can just apply this morph or this morph, whatever I wish to do. When I have those morphs dialed into the shape I wish, then I press just I in the keyboard while this dialog is open, and it makes a little tick mark here inside the current keyframe. It's hard to spot, but it's visible. And for the animation frames I need to press Ctrl I on the keyboard, and the second tick appeared here. Those are the first keyframes now. Then I can go into the next frame and change those positions, dial up the next shape for the morphs, and apply also keyframes. And those are separate keyframes, so they can differentiate in time the pose morph and the shape morph whatsoever. And just I go into object mode, shift, okay, next frame, press Ctrl I, and I can also change the morph values here, or combine them probably, and press I, and I go into next frame here. Ctrl I, and now I press Alt D to animate this one, and that's what it's doing. I just noted some inconsistencies. My latest thinking was that when I advance the time with morph list open, this object jumps into next keyframe. but if I exceed the last keyframe, then it cannot calculate the proper pose for this rig. I probably need to add a keyframe when I press enter. Then I go into this frame here. So I advance here in the late and press Ctrl I. So, and now when I go into a frame here, then this one holds. Alright. And then I press Alt-T to just play this animation here. And I quit this application right now, and let's check out those, when I delete those, this morph map, it hits morphs. What was the struggle in the code? And when I click on this morph map, those vertices belonging to this morph map become selected to be visible that this morph map consists of those vertices. And this one was a function here, select current morph map. This function is inside the selection task, but it uses a certain variable inside the morph system to find out what should be selected. And this one was here it deals with the vertices selection, and here it has this comparison here with morph, the former morph is here morph map, it's object morph map. And in morph system we have 4 types of structures or objects. The former morph map, the former morph, and object morph map, and object morph. And object morph maps are called just morph maps and morphs as a type. But here in this comparison we have this object morph. It references to the former morph. Let's see what type it is. An object morph map and the former morph map. So object morph map has it inside a reference to the former morph map, and it checks if this is true, and when it holds, then those vertices can be selected. And so it is a connection between those two types of morphs and morph maps. And this, because of this connection, the deleting was a very hard task. Let's go back to this deleting. Delete. It was remove. It was remove morph map. And here we can see that beforehand I had a task for removing as I imagined it should be, but it was not proper, and I had to reposition those blocks for for those tasks, and I still had anomalies that I select those morph map and those vertices didn't get selected after deleting this middle part. And this was very annoying because it means that the state is not proper, and you cannot anymore be sure what happens when you delete another one or create a new morph map on morphs. Then it gets messed up, and it was very hard to get it right. And I was printing out also diagnostic variables, their diagnostics. And I was checking everything there, and I just couldn't figure out how to solve this problem. And then I just spent several hours just making changes, reopening the file, doing it over and over again, and I couldn't figure it out. And then I just went to sleep and closed the program and the development and next and then while sleeping and resting, then I just came to a bigger picture at what it is about and what it's doing all around. And then I realized that those dependencies need to be released in a proper order, because they depend on each other. Because those deleting actions modify the arrays of pointers, and data inside those arrays need to be updated with new array. And here we see this called free the former morph map needs to be exactly in this place. When it's after or before, then it's doesn't work. But this was quite a trick to figure it out, because here in this freeing function, we can go into implementation. We see that this map is freed, and it calls free the former morph. It starts to release those created morphs one after another and go into this implementation. We see here it gets this morph, the former morph, and tries to release it also, erase from the memory. Because after we delete something, we need to free memories in the computer. And here is this object morph dialer sentence. And we need to tie out those object morph dialer variables from the real existing variables. And this is hard to explain, but let's check it out. Here it calls release object morph dialer dependency. This OMD is object morph dialer, and we go into implementation. Here it is, and here we see that inside this function it deals with this DEM variable, this DEM connection, and it sets it to null. And when we beforehand checked this vertice selection function, there it was also the DM line there, that it is very necessary, but it's buried so deep into the system that it is hard to comprehend what you should do. And when you cannot do it, it fails, then you are confused. And that's it for now.